Okay, yeah, I think we can start. Welcome to the first lecture of our course, Databases for Data Science. So before I introduce myself, I would like to introduce the main staff, which are our excellent TAs. We have Amina, who is also present. Hello, Amina. Then we have, I think it's Min sitting next to you. Yes, very good. Then we have Bo. I think he's in Zoom joining us today. And we have Raihan and Alexander. So you find a short bio of them and even a profile picture on our My Courses page. So they will be your main contact during the course. And feel free to reach out to them anytime you need something or you have questions for the course. I will tell a bit more how you reach them later. So I will talk about the logistics and the organization of the course later. But first, I would like to give a brief introduction into the course topic. So let me now share my slides. Can you see my slide? Yes, I see it. Very good. Yeah, so here you see a picture of me, which was last summer in Austria. I'm originally from Austria. My name is Alexander Jung. I'm associate professor for machine learning, so I'm not exactly from the field of databases. Hello? Yes, there was a small echo. Yeah, as you can see, I have taught here the courses that I have taught so far at Aalto, mostly machine learning courses. Also with now a focus on human-centered machine learning. I've taught artificial intelligence and more of the mathematical tools like convex optimization for machine learning. And it seems I did a good job. So the department leadership thought I would be the right person now to take over the databases course, at least until we have a dedicated professor for databases. But of course, as you might know, data and databases, they are very relevant also for machine learning. So I would see this databases course actually as the ideal entry point into this curriculum that consists here of the courses that I have taught so far or still currently teaching, like federated learning, which I'm teaching at the moment. So databases is really the entry point to machine learning. And so just to motivate, maybe to motivate you a bit why you want to learn all these abstract theories and techniques for databases. They are really the fuel of machine learning, and machine learning is everywhere, as you know, or as you might have observed. For example, we now find our jobs using machine learning assisted recommender systems. I, for example, found my job at Aalto via such a job ad on a social network called ResearchGate, and most likely some machine learning algorithm decided that this position at Aalto was interesting to me, so I applied 10 years ago, and now I'm here. Also, you find our partners, or partner, maybe here singular would be more suitable, on websites or platforms which use machine learning to suggest interesting profiles to you. And on a more mundane level or more daily basis, every time you use some streaming app or social media, you get typically suggestions or recommendations for content that you want to watch next. So we are pretty much already to some extent controlled by machine learning. So, and how does it work? So I like to think about this simple model of machine learning. So what machine learning does, it learns a function, or I call it a hypothesis map, that reads in features of a data point, and here already comes data into play. So a data point could be me, Alex Jung, and this machine learning system knows some properties of me which might be stored in a database, which you will learn in this course, how to build such databases. So my features, so this was a while ago, this was 10 years ago. back then. And based on my features, it decided that this job ad would be interesting to me. Another more recent example is autonomous driving. So machine learning models or trained machine learning models read in the current driving conditions, and then they predict what's the optimal steering direction, where to move next. Even more recent example, which has a lot of attention at the moment, large language models, which is used, for example, by ChatGPT. So a data point here is a user prompt, and the prediction or the output of this hypothesis map is the response text. And this ChatGPT has been very successful in learning such a hypothesis map in the sense that it keeps users going. So it's interesting what it produces. Might not always be correct or that useful, but at least interesting because so many people are using ChatGPT nowadays. Okay, so how does it work? Well, as I said, it's based on data. In particular, machine learning fits models to data to make predictions. And as this is not a machine learning course, I would refer to my follow-up courses or to my textbook, where I discuss or present this principle in much more detail. Okay, but just to give you a glimpse of this machine learning principle, I have here this little game which I like to show in introductory lectures. So, and you are now a machine learning algorithm. So you now observe properties, like you see here a sequence of numbers, and now you have to make a prediction. So what's your guess for the next number? Any brave students who make a prediction?
9.
Very good. So one prediction is 9. And can you explain why you predicted 9?
Because the sequence is increasing by 1 from 4, 5, 6, 7, 8.
Yeah. So what you have did, or one way to explain one way to look at it at the internal cognitive processes, you try to make sense out of this sequence, and making sense in the form of fitting a model like a straight line. So the model is here the collection of all straight lines, and you fit the straight line by adjusting the slope. So you see there's always increase of 1 from one sequence element to the next. So it seems the slope is 1. And then once you have fit the model, so you have found a hypothesis map, a straight line with slope 1, you just extend it and you make a prediction. And that's the basic principle of all machine learning, including ChatGPT. And so what you have used here is actually data. So you have used these data points that I have shown to you, the sequence elements. These are what I call data points. These are objects, abstract or physical objects that carry information. In this sense, in this case, the information was in the number itself that this sequence element represents, and in the location. So you also use the location of the sequence element. So this would be 2 properties of this data point. Here's another example. So I show you a sequence of geometrical figures along with a number. So this figure has 1. This figure I assign the number 1, and so on and so forth. So what would be your guess? What is the number that should be assigned to this figure here, to the last one on the bottom right?
So 1.
Yes, why do you think it should be 1?
Because when there's only one triangle, it's 1/2. And when there's 2, there's 1. So
yeah, so this could be one reasoning. So the 1 is the number of triangles divided by 2 or something. You could also come up with number 1 by saying it seems to be the area. So the total area of this geometric shape is the number that is shown here. So this has area 1, and it doesn't matter if we move the individual parts around. So there's some invariance regarding certain transformations. So it doesn't matter if you move the figure around, if you break it into pieces and move the individual pieces around, as long as they don't overlap, the area stays the same. And if you could speculate that if you feed enough of these examples to a machine learning algorithm, it might capture these invariances and learn to compute areas or to integrate. Okay, so one of the more frustrating examples, a while ago, we had something called COVID pandemic. And here we had data points being current statistics of infections. And you wanted to fit the model to predict how many infections will we have next week. And then you decide based on this if we should have a lockdown, yes or no. Okay, I guess you get the overall idea. And just to summarize, so the principle or the three main components of machine learning, as I like to present machine learning as a combination of three components. You have data in the form of data points, and you fit a model to these data points by minimizing some error measure, and this error measure is called a loss function. So these are the three components. And in my machine learning courses, I focus mostly on the models. So in federated learning, we look at distributed models. I also study different loss functions in my research, like how easy are the resulting optimization problems. So we want to minimize loss, so we get minimization problems or optimization problems. But in this course, we will focus on the data component. And actually, the data component is maybe the most important component of machine learning. Without data, you cannot do any machine learning. So this is really, you can think of data as the fuel or the oil for machine learning. And as machine learning is nowadays mostly what is used in AI, so data is the fuel of AI, of the AI age. So you now are in a very important course. So you learn about the fuel of our AI age, data. So, but what is it? I mean, it's easy to talk about data. It's a nice little word, cute little word. But what exactly is it? And in this course, we will try to approach this a bit more mathematically, a bit more systematically, how to capture data, how to model data. We will talk about data models. And one simple model of data is it's a set of data points. But what is a data point? What is then a data point? And for me, the best informal definition that I have come up with so far is it's just some object that might carry relevant information, some object that might carry information. And this can be many different things. It doesn't need to be bits or bits and bytes. Like here, this some item in Wikidata data could be a data point, some period of time. So I define a data point as being everything that happens between the 1st of January 2021 AM till 2nd of January 2021 PM. So one data point is just one period of time. A data point could be an entire country. So this is a place in Austria, in my home country, and we use all kinds of properties of Austria to learn something about it. Or a data point could be a protein. A data point could be a bridge, could be some construction, technical construction, and we would like to know, for example, how long will it hold, or will it be safe to use it? Yeah, so in the end, a data point is just some object that carries information. And here as a specific example of a data set, I have a set of data points where each data point is a cow. So this carries information in different ways. So you could use the height of each cow, the weights, the ages. You could use as relevant information to predict something. You could also use the stomach temperature. Nowadays, the farmers, they are very more like become more and more data engineers or data scientists because they collect a lot of data about their animals, like the temperature inside the stomach. And it, as I understood, this temperature measurements, they can tell a lot about the health condition of a cow or What should we feed the cow? But and now to build the bridge to data models, I would like to point out that it's not very handy to work with the real data set. Let's say you're working for a startup that wants to make recommender systems for the diet of cows. So you want to predict what should we feed a cow tomorrow or over the next week to maximize its milk production or optimal meat quality if you want to turn it into meat at some point. So and to work with this data set itself, you would need to travel to this nice place here in the Swiss Alps. So to access the raw data set, you must visit the cows and put a measure stick next to them, put them on a scale to measure their weight, put something inside their stomach to measure the temperature. So it's not very handy to work with the original data set. So we need something that is easier to manage. And here comes the data model into play. So we could think of a data model as an approximation. And one form of this approximation is like a table. And this will be the key object of our whole course. So this course mainly revolves around using such tables, or we call them relations. And the corresponding model is the relational data model. We use this as an approximation. It's way easier to access such tables and to work with such tables, like store them on a computer, share them among researchers, update them. Way easier to work with such a table than work directly with the original data set. So you could think of a data model as an approximation of real physical objects. Are there any questions at this point? Yeah, please feel free to drop questions in Slack and also in the Zoom chat now. I will try to collect them once in a while. Okay, so this was basically now my bridge to introducing the course the course structure and the course logistics. And let me repeat again, the main object of study in this course is this table, such tables or relations. And these tables are used as approximations or as models of real world data, real world or physical objects. Just to keep this in mind. Okay, so now we will have 5 modules. So the course consists of 5 modules where you will learn all the nitty-gritty details of working with such relations. So we will start with the first module, relational databases. Second module, relational algebra. Third module, normalization. Fourth module, indexing. And the last module is on transactions. So let me briefly give an overview of each of these modules. So the first module, relational databases, will teach you how to build a database as a collection of relations. So again, the key object in this whole course is a relation. And a relation is like a spreadsheet. It's a two-dimensional arrangement of elementary pieces of information. Like we would have here a table of students. So the real world objects would be students like you. And this here is an approximation of your data set, of the data set that you represent. And this relation here contains different attributes for each student. There's one student named Alice. The major is computer science, and the year of registration maybe is 2024. So this relation consists of rows, each row being one elementary data point, so to say, or we call it tuple in relational language or relational database language. This is called a tuple, one such row of a relation. And we have for each tuple, we have different attributes. Each tuple has different attributes. So like in this here, we have a student ID, name, major, and year. Okay, then we have a module on relational algebra. And in relational algebra, we mainly study a language or languages for building new tables or relations from existing ones. So that's the main idea of relational algebra. And you can think of relational algebra as being the fancy version of another language that maybe some of you have heard, which is called SQL, SQL, structured query language. So SQL is the everyday version of relational algebra. So in the end, these are formal languages for building, mainly for building new tables from existing ones. And you can think of these new tables that you build as being answers to questions or queries. For example, you want to find out, here I have shown an example where you query a table of students for all students whose major is CS, computer science, and the year of registration, I guess, is at least or is not earlier than 2024. So this is one query you want to know. You want to know what are the which one of the students has major computer science and has registered not before 2024. And you can translate this query that I just formulated in natural language in my German English. You can translate this into a formal language, which is a relational algebra. And here you see this algebraic expression in this snippet here. And the meaning, so to say, the meaning of this expression is a new table. So you construct a new table that contains exactly the students whose major is computer science and which didn't register before 2024. So the meaning or the evaluation of such an expression gives you the response to a query. Okay. Then we will have a module on normalization, because often you can have different equivalent databases or relations that represent the same information, that contain in the end the same information, but they differ in certain aspects. Like some variant or some of these relations have more redundancies than others. For example, I show here one relation that I just downloaded from the Finnish Meteorological Institute, which contains temperature recordings. And so this relation has the attributes name, the name of the weather station, then the latitude of the weather station, the longitude of the weather station, a timestamp of the weather recording, when did we take the weather observation, and the value of the observation, of the physical quantity, the temperature. And you see here there's quite some redundancy, because for each recording from this weather station, we always have latitude and longitude. So this here seems highly redundant information. So we could instead have a separate table where we only store apologies. Oh, getting a bit messed up here with my Zoom. So instead of this redundant information, a redundant table, we could have a separate table which only stores the latitude and longitude of each weather station. And here in this table, we only refer to the weather station using its name or some ID. So this will be the core technique to normalize a database, is often to break it into smaller relations that have less redundancy. So I see one question on the chat. The question is, in relational algebra, why would creating a new table be helpful compared to searching in the old table? Yeah, very good question. Well, this is exactly what is done. So you can think of a query or formulating this algebraic expression as formulating the search criteria. So evaluating the evaluation of this relational algebra expression is exactly to do the search. So you represent the search, or you encode the search criteria in relational algebra. So this is actually the way you implement the search. And the new table, you can think of the new table as the temporary results of the search. This is the results that the search delivers. Yes, any other questions? Do not hesitate to post them on Zoom or in Slack. Okay, so normalization is important to avoid redundancy, and also it typically prevents mistakes. Think about we correct the latitude and longitude of this weather station. Because the original latitude and longitude was erroneous. We made a GPS, we had a GPS measurement error. So once we have now a new latitude and longitude, we would need to replace all these entries in this table. And if we miss one of these rows, we would have inconsistent data. So we would have all of a sudden 2 rows with the same weather station, but at different locations, which doesn't make much sense. And when we normalize this database, so we avoid this redundancy, we also minimize or we reduce the risk of such update anomalies or errors. And you will learn how to implement such database normalization in module 3. Okay, then the 4th module will be on indexing, also an important topic for databases. And yeah, as the name already hints at, and maybe you have came across this before, an index is like for a book. So here I am currently working on a dictionary of machine learning, and you can think of this dictionary as a database. So each entry in this dictionary is one tuple in this database. And to search a certain term, let's say the term data, you could browse through this dictionary one page after the other until you find it, or you use the index. So you look up in the index for data, well, it's not here, but let's say you want to know cluster. Okay, here is the index term cluster. It's at page 22. And similar, we use an index for databases. In databases, we want to look up a certain entry or a certain tuple based on a given identifier. Like here, the identifier is the index name or term, cluster. And the index then shows us where this database entry or this tuple is stored in memory. Like here, it's the memory is the PDF, or if you print out the pile of pages, is the memory, and the index tells you on which page can you find the entry for cluster. Okay, and the last module 5 will be on transactions, which is then a bit more advanced, because we now need to take into account the implementation of a database. So a database or a database system, database management system, often must serve more than one user. And it's actually, I mean, I cannot think of a database system that only serves one single user. If you come up with one application, please let me know. So it's almost useless to have a database system that only works if there's only one user working on this database. So you will have concurrency. You will have a system, for example, a database system. I could mean a web server application. So you develop a Python code that runs on a web server which has this IP address, and this Python code manages the database. For example, it processes user requests, and here I have shown 2 code snippets in Python that could actually implement such user requests. So you have here user 1, which formulates a query. So this is this is this SQL language that you see here, and you will learn it also during this course. You will learn how to use this SQL language within Python. So you will actually learn at least 2 new languages in this course. You will learn SQL, you will learn Python, and actually, strictly speaking, you will also learn a third language, relational algebra. So this course is essentially teaching you a lot of languages. And yeah, so you use here this SQL query to implement or to set up a request. And this request can be implemented in a lower level, for example, by IP sockets, so by some lower level technology, which is not really relevant here. But at any time, and this can be arbitrary, can be exactly at the same time another user also accesses this web server that manages the database. So what happens if they access the same element of the same table in the same time? And one of them writes or changes, modifies this entry. So let's say one user one, changes the information for the cow Zenzi. And the other user also changes this information for the cow Zenzi. And what happens if they modify this tuple not at once but step by step? So user 1 starts to rewrite this tuple while user 2 is still working on it. And this results in what is called conflicts, and we want to, of course, minimize these conflicts. And one way to minimize conflicts is using so-called transactions. So these transactions is a mechanism to make sure that once a user starts to write a tuple, it's blocked for any other user. So you cannot, these users cannot override each other's requests to some extent. And you will learn how to implement simple form of transactions also in module 5. Okay, that was all for the introduction. Before I move on to the course logistics, please let me know if you have any questions. Okay. If you have not any questions at this point, yeah, I will now walk you through our My Courses page, and this will be our main platform. So I will try now for this course, this will be my first course maybe, where we really have everything at My Courses. There's already one exception, the discussion forum is on Slack. But I learned that students find it challenging often if we have too many platforms. So we will really have everything related to the grading will be on My Courses. Yeah, you see here the overview on the general page. As I mentioned, we have 5 modules. Each module corresponds to a certain part or sections of the course book. Our course book is the Ullmann-Widom book, a first course in database systems. The 3rd edition, Pearson edition from 2014. Yeah, please be careful that you pick the right edition. Otherwise, the section titles might not match or might be different than in our references. So we always refer to this 3rd edition, Pearson edition. And this should be available as ebook via the Aalto University Library. So if you click here, you should get directly to the book. Yeah. Okay, so each module follows closely a selected set of sections of this book. So I highly recommend when starting to work on a module, start with carefully reading the indicated sections. So for the first module, we have section 1 and 2 of chapter The Worlds of Database Systems, and section 1 and 2 of chapter The Relational Model of Data. So the first step would be that you read those sections. Then for each module, we have a quiz which tests your understanding. of the module contents, in particular, essentially of these sections, of the book sections, and we test them by a quiz. So we will open today at 6 p.m., so quite soon. We will open all quizzes at the same time. But you have different deadlines. Please note the deadlines. So the first quiz will be due on the 29th of April, second quiz on the 6th of May, third quiz on the 13th of May, fourth quiz on the 20th of May, and the last one at the 27th of May, always 1 minute before midnight. Yeah, but before starting the quiz, I highly recommend to read the corresponding sections of the course book. Beside the sections of the course book, we also have prepared some simple notebooks, Python notebooks. So you can use those to practice the concepts in Python, and you can use whatever environment you want. So you can run those notebooks, those Python notebooks, on your own computers, or you can use our Jupyter Hub server. So I think we have prepared the link here. If not, we will shortly provide the link for this Jupyter Hub server. But just to walk you through how you can use the notebook with our Jupyter Hub server. So you can download all the files required for this demo. So it's not only this notebook file here, but you also have some data files, some support files. And I recommend to download the whole folder from my courses. And then you can log into Jupyter Hub. So this is really convenient if you don't want to mess around with installing Python on your own computer. As soon as you have auto credentials, and you need auto credentials to log into my courses, for example. So when you're able to log into my courses, you should be able to use this service. So let me restart quickly my server, stop my server. And you can think of this server as like a virtual computer. So you can control this computer via your browser. The browser is basically the desktop. It's the desktop for this virtual computer. And you can choose different configuration for this computer, which are called server options. And for this, you can use the basic, the first one. The first option is fine, general use. And then you start the computer here by clicking the start button. Takes a while. Okay, and so this, as I said, this web browser, this runs on my own computer, on my laptop. This is a web browser, but it actually is now the desktop for this virtual computer. So you can, for example, if you want, you could launch a terminal. So you can look around what is on your computer. It's like it has its own folder structure, file system. It's really like a virtual computer that I control, or with user interface being my web browser. It's pretty nice, because the only thing you need on your own computer is a web browser and an internet connection. Okay, and now I could upload this demo that I just downloaded. Yeah, it can. Is it able to unzip? Okay, it cannot unzip. So I should download it manually, but I have already downloaded it before, so I can just use it here now. Yeah, just that you know, here you have this button to upload upload files, and there you can also upload a folder. But it seems with the zip file, it cannot directly unzip. Well, whatever. So as soon as I have this Python notebook here, I can open it, and then you can run through it. So it has some explanation text. This is like a narrative, like slides, and some code blocks. So these code blocks are with this gray background, and here you can see how to implement the concepts in Python. Here you have the first demo, which creates a table. You create a table or relation with a given name. The name here is movies, and then you must specify the attributes. So each entry or each tuple in this movies table has a title, has a year, a length, and a genre. And for each attribute, you must specify a data type or domain. Okay. So I also encourage you to work through, to browse through these notebooks. So these are just demos. You don't have to do anything. You can, if you want, you can modify, you can play around with these code snippets and modify a bit the code examples as you wish. Experiment with different settings. But it's also fun if you just try to understand all these code snippets or their function. Okay, so maybe I would now try out one interactive event, which is a quiz. And I would like to know, at least from those who are in Zoom, how many of you have used Python before? So please try to respond in Zoom. Okay, so it seems that the majority has used Python or did program in Python already a lot. Somewhat, so more than 60% used it a lot, around 30% somewhat, and very little, only one so far. Yeah, I just point out that of course we didn't put Python programming as a prerequisite. So everything you need from Python programming will be taught slowly within this course, or you will be provided material to acquire these basic Python skills. Maybe to show you to what extent you need Python. You need Python in some of the quiz questions. So now where is my courses page? It's gone. Let me recollect myself. So if we look at the quizzes, then for some of them, you need a bit of Python coding. So share again. So if we look at quiz 1, which will be due in around 2 weeks, so I can preview it now. And there will be mostly multiple choice questions. Like this here. Which of the following best describes a database management system? Choose one. And these questions are based on this corresponding sections of the book. So if you read the book sections carefully, you should have not a big challenge to find the right answer. But some questions are actually coding questions, not here. The first one doesn't have one, which is actually good. So you have a bit more time to get familiar with basic Python coding. Let's look at the next quiz. And yeah, by the way, you have one attempt. So for each quiz, you have one attempt, one single attempt. but the attempt can be arbitrarily long. So it can be 10 hours, 20 hours, 7 days, 2 weeks, but you have only one attempt. What else should I say regarding quizzes? You can reobtain points. So if you think it was very unlucky that you lost some points because you misunderstood the question, or the question was formulated a bit vaguely, or some of the answer options were vaguely, do not worry. You will have, at the end of the course, you will have the opportunity to book a review meeting with me, where we can rectify all these boundary cases, okay? Where you can reobtain the points that you have lost because of unclear formulations of these questions. Yeah, what else? Yeah, we will randomly select, since this course is involves a lot of independent work, so we will not sit next to you when you attempt the quiz. We cannot, we simply cannot. But we will randomly select always a few students who have to explain their solutions in one of the exercise garages. So be prepared that we might select you to explain your solutions. So just blindly copying from anybody else the solutions might be risky if we then invite you for presenting your or explaining your solutions in one of the garages. But before I tell more about the garages, I just want to show you one of these coding questions. Yeah, here's one. Here's one. So you have to, this is the question, and your answer will be in the form of a short, actually you don't, for the quizzes, you don't need Python at all. You just need SQL code a bit. But for the final assignment, you will need a bit of Python coding. And also the final assignment will use such a code runner question. And in this code runner question, your answer is code. And here we ask you for Python code. And I will just now randomly provide an answer from A, select B, some SQL code that you can then check. And this will be most likely wrong. Yeah, will be most likely wrong. And for this code runner problems, you can retry, you can check your answer without limit. So we will not penalize if you then need to revise your code and then check again. So I now change it and check again. I guess it's still wrong. Yeah, it's still wrong. And you can do this an unlimited number of times. We will not deduct points for these iterations in the code runner questions. However, as I said, for the whole quiz, you only have one attempt. So once you open the quiz, that's it. That's the only attempt that you can start. Any questions at this point? Okay, then I mentioned already the project garages. So this course is more like a flipped classroom course. So we will not have any more lectures, traditional lectures, where I present 100 slides or so, because I think the best way to learn these basics of databases and the relational model is by doing. So you actively working on the quizzes and working on the demo notebooks. But of course, whenever you have a question, you can reach out to the course staff, like via the Slack. So we have a Slack. Those of you who have not joined the Slack, please do so. I have sent an invitation link to Slack in the first My Courses announcement. So if you have not joined Slack, the discussion forum, please now join it. And in this Slack, you can also book one-on-one support sessions that are offered during so-called exercise garages. And you see here the timing of these garages. For example, tomorrow we will have one garage in in a CS building. So there will be one TA present in this indicated room, and at the same time the TAs will be available online in Slack. So if you for example have now a question about what I talked about today, you can go to this garage tomorrow between 10:15 and 12. Either you can go to this lecture hall, or you visit this garage's queue channel on Slack, like here. So you will go into this channel. And then during this exercise garage, there will be TAs available and try to respond to your request. So then you write, hello, I need help. Then, for example, we could now demo it with Amina, if possible. Yeah, Amina then, one of our TAs, then marks my request with this hammer symbol, which means this request is processed at the moment. So Amina would then send me a direct message, I guess. Yeah, so Amina then sends me a direct message, and then you can either discuss by text. So I have my problem here, or Amina can propose what is it, a hangout or a huddle? Is it a huddle? Yeah, huddle. Then you can have this huddle, like online meeting. Very good. And yeah, that's how it works. That's how you get help from the exercise garages. And once this problem is resolved, you see here a check symbol. So if you are also waiting for getting help, you can see from these symbols how many people are currently processed. So how long you would need to wait to get your problem, to get a response from the TAs. So if you only see this hammer symbol, this means in process. If you see a hammer and the check, this means this is already covered, this request. So you don't need to wait for this one to be handled already. Okay. So please join Slack. If not done already, this will be our main communication tool for arranging one-on-one support for you. Okay, so now I have discussed the quizzes, the notebooks. We have five of them, yeah, one for each module. And then we will have a final assignment. We are still preparing this, so we will release the details by end of next week, I hope. But there's not so much rush because the deadline for this final assignment will be end of May. And in this final assignment, you have to apply all the skills that you learned during the modules to implement a weather forecasting system. So you will use databases to store weather observations from the Finnish Meteorological Institute, and then to use that database to provide predictions or forecasts for the temperature at the given day. So the user is interested what will be the temperature in Helsinki tomorrow at 3 p.m. and you will then try to deliver or to serve this query, so to say, by a prediction. Okay, but we will provide more on this final assignment at a later point. So for now, I suggest you focus on this module, starting with module 5. We will open this maybe right after this lecture. So the quizzes will open after this lecture. You can then read also access the notebooks. So I highly recommend before you start the quiz, read the indicated sections of the course book and work through or walk through the notebooks, the Python notebooks. And once you have completed this, start the quiz. That's my recommendation. Okay, regarding the final grade, I guess some of you want to have a grade for this course. You collect in each of these modules, we have 5 modules, and each module is worth 10 points, which makes total 50 points. The final assignment itself is worth up to 50 points, so you can collect in total up to 100 points. So far, so good. And the total grade is then quite straightforward, from 50 to 59 points, grade 1, starting at 60, grade 2, starting at 70, grade 3, starting at 80, grade 4, and starting at 90 points, you get the top grade 5. And yeah, just to remind you again, if you feel like you lost points because of some misunderstanding or an unclear formulation or some other unforeseen coincidence, you will have the opportunity for a review meeting with me where we can discuss all these unfortunate events and potentially rectify any lost points. So don't worry about this too much. Okay, any questions at this point? Also on Zoom, I don't see any questions in the chat. So that's it from my side. Welcome again to this course. Yeah, and I look forward to guide you through this boot camp for relational databases, so to say. Yeah, thanks a lot, and then have a nice rest of day. Bye.